Hello everyone, welcome to my new video on my Mathematics Essentials series. In this video I want to introduce the sine rule and give a proof. So the sine rule with proof. Okay, there's a few ways of proving the sine rule. I might do two proofs in this video, or I might save the other proof for the next video depending on the time. But to start, I should say what the sine rule says. So let's say we have a triangle and the angles of the triangle are labeled as follows. So each of the angles are labeled with uppercase letters, and the corresponding side length spanned by any angle is labeled with the corresponding lowercase letter. So the angle A spans the side length lowercase a, and similarly for the angles B and C, and the side lengths lowercase b and c. Then the sine rule says that this formula holds, that the sine of the angle A over its corresponding side length A is equal to the sine of the angle B over the corresponding side length B, which is equal to the sine of the angle C over its corresponding side length C. And with some algebraic manipulation, you can rewrite this with the side lengths in the numerators and the sines of the corresponding angles or the opposite angles to those side lengths in the denominators. Okay, which way you write it really depends on what you're trying to find in the problem that you're given. Okay, if you are trying to find an angle, well, it makes sense to put the sines of the angles in the numerators, and if you're trying to find a side length, it makes sense to put the side lengths in the numerator. Okay, both ways will get you there. It just saves you a little bit of algebraic manipulation. Okay, now the sine rule and the other rule, which is the cosine rule, they're also known as the law of sines and the law of cosines. They are useful rules or laws or formulas for working with triangles that are not right angle triangles. Okay, so let's go ahead and prove the sine rule. And I want to have another copy of this triangle. So I'll just copy and paste it. And I'll move it over here. And you'll see why I'm doing that in a second. I don't really need to do this. I just in case anyone's sort of worried about a little bit of hand waviness in the proof, I'm going to circumvent that by having two triangles, or two copies of the same triangle. Okay, and in this triangle, I'm going to draw a perpendicular. So I'll have a perpendicular line segment that comes from the angle A to the base of the triangle. Okay, and that's really going to split our triangle up into two right angle triangles. So I'm going to talk about the triangle on the left as, the red triangle I'll call triangle 1, and the triangle I'm indicating with green here I'll call triangle 2. So that's the triangle on the right. And this perpendicular line that I've drawn, I'm going to call h for the height of the triangle. Now, what I'm going to do with the copy of the same triangle is basically the same thing, but I'm going to have the line come out of the angle B. Okay, so this line segment that I draw between B and the side length, the opposite side, lowercase b, okay, that's also going to split our triangle up into two right angle triangles. And now that we've split our triangle up into right angle triangles, we can talk about sines and cosines with more simplicity, and the proof will be, well, we can do the proof now. So if you consider the way I've labeled the triangle here with the height h, I'll just label this one h dash actually. Okay, should give things names if I'm going to talk about them. So that line from B, from the angle B to the side length B, is h dash. Okay, now if you look at the first copy of the triangle, okay, we can see that the sine of B, which will be opposite over hypotenuse, okay, the sine of B is going to be equal, well, the opposite side is h, okay, and the hypotenuse in triangle 1, the triangle on the left, is c. Okay, so from this, if we multiply both sides by c, we obtain an expression for h equal to the side length c times the sine of the angle b. Okay, but we can do the same thing, okay, in triangle 2, or the triangle on the right hand side. Okay, we can take the sine of c, and that's going to be opposite over adjacent. Okay, so the sine of c is opposite over adjacent, but the opposite is h. Okay, sorry, opposite over hypotenuse, and the hypotenuse is b. Opposite over adjacent is tan. Now we can get an expression for h just by multiplying both sides by b. So we have that h is equal to the side length b times the sine of the angle c. So now we have two expressions for h, right? Which means we can equate them. So we have that c is equal, or c times the sine of b is equal to the side length b times the sine of the angle c. Okay, and now we can divide both sides by bc. And we can see on the left hand side the c's will cancel, and on the right hand side the b's will cancel. Okay, so we obtain the result that sine of the angle B over its corresponding opposite side length, B, is equal to sine of the angle C over its opposite side length, C. And now you could argue from symmetry that this holds for sine of the angle A over its corresponding side length, A. But if that feels a bit hand wavy, or just to alleviate any doubt, that's why I drew the other triangle with this line H dash. Okay, so I'll just talk about the upper triangle being this one, and the lower triangle being this one. Okay, we can make pretty much the same argument with the sine of A. So if we take the sine of A, I'll use white. Okay, so the sine of A, sine of the angle A, is going to be opposite over hypotenuse. Okay, in the upper triangle, okay, the opposite is H dashed, and the hypotenuse of the upper triangle is C. Okay, so we can obtain an expression for H dash being equal to C, or the side length C, times the sine of the angle A. Okay, but we can also do this for the sine of the angle C in the lower triangle. So sine of the angle C, sorry, I said C and went to write A. Sine of the angle C is equal to opposite, well, that's H dash again, over hypotenuse. And in this case, the hypotenuse is A. That's the hypotenuse of the lower triangle. And here, by multiplying both sides by A, we obtain an expression for H dashed being equal to the side length A times the sine of the angle C. Okay, so with two expressions for H dashed, we can equate them, and we have the equation that C times the sine of A is equal to A times the sine of C. And now if we divide both sides by AC, okay, we can see that the C's will cancel on the left-hand side, and the A's will cancel on the right-hand side. So we get the result that, that the sine of A, the sine of the angle A over its opposite side length A, is equal to the sine of the angle C over its side length C, which means we can go back down to this equation, and we see sine A over A is equal to sine C over C, and we have sine B over B equal to sine C over C, so both of them are equal to the sine of the angle C over the side length C. So we can write in that the sine of the angle A over A is equal to the sine of the angle B over its corresponding side length B, and similarly for the angle C and its side length C. So that completes the proof of the sine rule. And in the next video, I will reprove the sine rule in a similar way, but it will be slightly different. So if you enjoyed this video, feel free to give it a like or to share it with some friends. And if you have any questions, just post them in the comments. If you want a notification when I upload a new video, just subscribe to my channel. Until next time, bye for now.